Welcome to the MS SQL Tips webcast, HA for SQL in the Cloud, an expert panel discussion sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's host for the webcast. Joining me today is Dave Bermingham, Mike Traudt, and Heath Carroll. Dave is a technical evangelist at SIOS and a Microsoft Cloud and Data Center Management MVP with many years of HA experience. And Mike is a SIOS Senior Solutions Architect with 16 years experience in high availability, disaster recovery, and backup and recovery. And Heath is a SIOS Software Engineer who provides the engineering team with in-depth expertise for cloud deployments. Today they will share with us things we should know to have a successful HA deployment in the cloud. Before we get started, if you have questions, you can submit them any time during the webcast by entering your questions in the question area in your presentation controls. We'll answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, also use the question area to let us know. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's webcast. So today we're going to talk about moving SQL Server to the cloud. And the trend these days is more and more people are moving to the cloud and have questions about what is the best way to deploy SQL Server and what is the best way to implement HA solutions in the cloud due to some of the limitations that the cloud presents, as well as some of the technology that SQL Server has to offer. So 3 experts from SIOS are here to help answer some of the frequently asked questions that they hear day to day about clustering in the cloud. And they'll give us some insight as to how they handle these things, working with their customers, and how SIOS handles things with some of the tools that SIOS has to offer. So why don't we just jump right in this, and we'll start with the first questions. So to start us off, Mike Traudt, as I said, is a Senior Solutions Architect at SIOS, is going to help us answer some of these questions. So some of the questions that they face on a day-to-day basis are, do I need a cluster in the cloud? And doesn't the cloud offer SLAs where, therefore, there's not a need to have HA in the cloud? So Mike, if you want to take those 2 questions and let us know how to handle those things.
Yes, thank you, Greg. So do I need a cluster in the cloud? The SLA is advertised in the cloud, and you see failover zones or relative terminology across all 3 of the major providers, whether it be Google or AWS or Azure. All of them advertise the same resilience capabilities, but that level of resilience doesn't necessarily propagate all the way to the customer application, because that application is inside of an operating system. And yes, the operating system is using these resilient interconnects and maybe even resilient copies for business continuance purposes or even for DR purposes. But for high availability, all of these things have to be so-called interconnected and aware of each other. So that's where the SIOS solution really steps in, which we'll address in a few minutes, but there is a major differentiator between high availability and service level agreement levels of subsets of that enable the HA. The next question, Greg?
Yeah, and along with that, Microsoft's really been pushing SQL Server Always On, and more people are looking at implementing that in the cloud. So isn't that good enough just to use Always On to handle the HA solutions in the cloud?
Yes, and if you had deep pockets, you could get all of the licensing required for Always On. But then again, it's required per node cost. The cost related to enabling enterprise licensing, depending on which version of SQL and OS you're talking about, the cost becomes extremely expensive, first of all. And it's not necessarily resilient in the way that the SIOS ability enables us to not only do things for SQL, but other applications and even generic apps, which you can configure your own type of synchronized data copies. So the most common issue here with Always On is the licensing topic. With the SIOS solution, you don't have to have the enterprise level licensing, and the Always On does log replay, so there are things on the wire prior to particular confirmed acts back. So the HA level with always on is not quite as robust and flexible as far as number of copies available, et cetera, compared to a SIOS related solution.
All right, so I guess the other thing too, Mike, if you can kind of help let people understand sort of what a traditional cluster looks like and why this doesn't work in the cloud.
Right. I mean, first and foremost, the traditional clusters have an object with shared storage resources, right? And you could just click through the automation here. That shared storage element requires a lot of sensitivity in relation to the bit settings per host, and you need enabled storage that can actually deal with the shared reservation topologies. So that requires a whole lot of expertise and awareness, but at the end of the day, even if it's shared storage, that one thing goes away and everything goes down. I don't care how many hosts are connected to it or seeing it concurrently. It's a single point of failure, and that's what we're trying to avoid for a more robust HA topology. So we'll go to the next slide.
All right, then if you want to just share with us sort of how SIOS DataKeeper sort of can take care of implementing a cluster in the cloud.
Right, so in this case, the SIOS method uses replication between two separate disk resources that are aware of in the OS. So these two separate disk resources are replicated synchronously or asynchronously, by exception, across the LAN or WAN. So in this case, I don't need to have a shared storage resource. And as we know, it'd be few and far between where you would actually have access to a storage array in the cloud. It just simply doesn't exist unless you're in an MSP type of environment. So in this case, we're really relying on the core nuts and bolts of a topology that exists in all of the cloud providers, and using the LAN or WAN with resources that are owned by the operating system, we can create a low latency block level replication as efficient as possible between a number of server nodes. It doesn't have to be just one or two, but this could also feed use cases for DR and reporting instances where we can break off that copy and run reporting on an alternate host. So there are a number of use cases that sort of are the rest of the SIOS story that we won't have time to today, unless somebody asks questions related to it. But that's the basic topology here. We can go next. In the failover situation, not only can we fail over the SQL Server application layer using the integration with Failover Cluster Manager, but also the replication will fail over and take over. And once that host is back online, it will automatically resynchronize those blocks in an efficient way because we utilize this bitmap technology that sort of does a subset of whatever data is not in sync with whoever owns the primary copy currently. So as far as the DataKeeper cluster edition in itself, which is the most commonly used version of SIOS, the DataKeeper cluster edition is fully integrated with server failover clustering. So that Windows Server failover clustering is a tried and true since 2K8R2. It's been very stable and very reliable, and more importantly, most integrated with the Windows products, especially SQL. So we can go through MS SQL and Dynamics and Link and SharePoint, et cetera. And that failover clustering, we don't have to worry about necessarily because Microsoft has done all that work. But that awareness and the integration with the Windows Server failover clustering enables us to go hand in hand with all of the resources that the cluster owns, plus making it aware of the disk and the synchronization of that disk that we own at the DataKeeper level. But so it's a minimal replication overhead, as I mentioned before, because we utilize this bitmap technology, and it's optimized for LAN or WAN because we can flip a bit to go asynchronous. And the intuitive MMC interface, when you are in failover cluster mode, you'll see hints of a DataKeeper volume, but at the same rate, when you go into the DataKeeper interface, it just looks familiar and the ease of use is there. It's you really need no particular expertise to manage the environment. Most people just sort of set it and forget it. And the failover cluster manager is all they live in their day-to-day environments. Of course, there are a number of interfaces for CLI to get status and things like this. You can have CLI control all of your copies too, like the use case of disaster recovery or breaking off a copy and pausing a mirror to make it readable on the target side for reporting offload. The use cases continue on from there. And DataKeeper replication, the host-based data replication, we can leverage the LAN and WAN like I mentioned. I can have multiple targets, I believe up to 16 copies from the primary copy. So that really opens up the ability to get this topology wide open for whatever use case may come to mind. And it's at the block level. When it replicates, it's replicating at the block with equal size volumes. And it's change-only replication utilizing that bitmap file. And of course, the modes of synchronous, asynchronous are all driven by change rate, bandwidth, and latency, depending on your particular metrics in your environment.
All right, and Mike, just to clarify, so the cluster that you're talking about is the same traditional cluster Microsoft offers for whether it's on premises, so people don't need to learn anything new. Is that true?
Yeah, right. Well, at the UI, it's the same story, but we actually offer more efficiencies because we don't need necessarily enterprise editions to enable the level of replication that SIOS would deliver. So we can even save in licensing at the top end, much like the AAG story. That sort of enables a lot more features and replication tiers than you would expect using traditional Microsoft methods. So a lot of customers are really enamored with that story as opposed to just describing what Microsoft SQL and the OSs / applications have been advertising and selling for a number of years.
All right, so we're going to actually move on and get some information from Dave Bermingham, who's a senior technical evangelist at SIOS and also Microsoft Cloud and Data Center MVP with lots of experience in the HA world. So Dave, so what are some of the common configurations you're seeing for HA for SQL Server in the cloud?
Yeah, thanks, Greg. I think I'm going to talk about both these questions at the same time. So we're going to go through some common configurations and throw in some of the cloud witness, the witness options and the quorum options as we discuss. So let's go to the first slide. The first slide is probably the most common configuration I'm seeing in the cloud, where people are, basically moving, either putting new applications in the cloud for the first time, or they're doing a lift and shift where they're trying to emulate what they have on premise in the cloud. And so it really turns into a basic 2-node SQL Server failover cluster configuration that kind of looks like this. Each cloud vendor has their own name for things, but essentially you pick a single region, so US East or West or whatever it might be. And then within a region of a cloud, there's typically silos. Amazon will call them availability zones. In Azure, we'll call them fault domains, but they're essentially silos that are independent of each other, so there's no single point of failure between either of these availability zones. And so you'll have one node of SQL Server in one, let's call it availability zone, and another SQL Server in another availability zone. And that ensures that you have redundancy. And that's typically what's required to qualify for the cloud SLAs. Microsoft, for instance, offers a 99.95% SLA, ensuring that if you have 2 or more servers deployed in the cloud, and those servers reside in different, what Microsoft calls fault domains, then they will guarantee that at least one of those servers will be available at any given time, 99.95% of the time. So they're allocating for, just over 10 minutes of downtime per month and still be within the SLA. But to do that, you have to have your nodes in different availability zones, fault domains, and so forth. So that's really kind of the starting point where people are moving their workloads into the cloud. You see pictured here is a file share witness. So without getting too deep into the weeds, if you're familiar with clustering, there's something called the quorum. And the quorum essentially is what the cluster uses to decide which node comes online. And Microsoft uses a node, and in this case, file share majority quorum, to determine which node comes online. In any cluster, you need to have a majority of votes. So what's pictured here, if SQL Server 1 failed, the file share witness and the backup node would form a majority, would be 2 out of 3 votes, and it would come online. So that's important. Now, what you have to consider about the file share witness is that it ideally would be placed in a third location or third silo. So either a third fault domain in Azure or a third availability zone in AWS. And that's to ensure that the failure of a single availability zone would only impact one of your votes. And that comes into play particularly when you're looking at AWS. There's some regions that only have 2 availability zones. And so in that case, you don't have the capability of putting a file share witness in a third zone. So for those circumstances, if you say you're going to deploy in Ireland, which has 2 zones, you're going to have to think about where you're going to place your witness. If you place your witness in one of the 2 zones, if that zone has a failure, you lose 2 votes out of 3, and then the standby server will not come online automatically. So that's not ideal. So you have a couple alternatives. One is with Windows Server 2016, Microsoft introduced a cloud witness. Essentially, you can leverage a Azure storage account to act as a vote in your cluster. So it eliminates the need for the file share witness by leveraging a service that Microsoft can provide, and that could be a vote. And that would be my recommendation if you're running Windows Server 2016, especially in Azure. It's kind of a no-brainer because you're using Azure anyway. But even if you were in AWS or Google Cloud, there's no reason why you couldn't leverage the Azure storage account as a witness, even in those circumstances. So let's move to the next slide, Greg. So in this next slide is a couple, two other pictures, and these are the other configurations we're seeing. So right off the bat, people recognize that having your 2-node failover cluster in a single region could be susceptible to a outage, whether it be a natural type disaster that would impact an entire region, or a man-made, human error, which we certainly have seen a few times across all the cloud vendors, which would impact multiple availability zones in the same region. So they're looking for some resiliency for regional type failures. So pictured on the left is what we call a multi-node cluster. So as Mike mentioned earlier, with the SIOS DataKeeper solution, you can have multiple targets. So you're not limited to the 2-node configuration. You can replicate data out to a 3rd node, a 4th node, and so forth. So a very common configuration is having a 2-node failover cluster in a single region for high availability, but yet replicate asynchronously to a different region for disaster recovery, just like you would today in your traditional data center. If you if it's critical, you're typically looking to move that data off premise to a DR site. And the beauty with the cloud is you don't have to manage a DR site. Microsoft or Amazon are already doing that for you. They have different geographic locations that you can leverage with not a bunch of additional costs. So it really makes a lot of sense to do that. So putting a third target is a very simple process to do that. Or even if you're concerned about the outage of the entire cloud, let's say there's some really horrific kind of human failure, which it's not unheard of, that would impact multiple regions. You could span, AWS to Azure to Google. You could span clouds, or you can even leverage your own data center as a DR site. So, there's all sorts of possible combinations, and that's what people are looking to do. They're looking to get their data from, a single region into a different region. Now, the cloud vendors, they could have some solutions that help you do that. But there are certainly some limitations. So in Azure, geo-redundant storage would guarantee that at least your data is replicated across geographic locations. But when it comes to SQL Server, they recommend you turn that off because they can't guarantee that if you're using multiple volumes, which is their recommendation, they can't guarantee that those volumes are going to be in sync at the same point in time. So you wouldn't want to have your log and data files from different points in time. You're not going to have a usable database at that point in time. So with a DataKeeper solution, we're able to do asynchronous replication of multiple volumes across regions and still guarantee right order integrity across those data sets. So it gives you a much more robust, reliable solution that's going to give you pretty much the best recovery time objective and recovery point objective that you can hope to achieve for your disaster recovery solution. Now, on the right is another configuration we're seeing where people are kind of dipping their toes into the cloud, and they recognize the value of leveraging the cloud as a disaster recovery site. So you have a local failover cluster, maybe leveraging shared storage as pictured here, and you simply want to extend that existing cluster into the clouds. And so with the SIOS DataKeeper solution, we can work in that scenario as well. So we can let you replicate your data from on-prem into the cloud and have that cloud as a node for disaster recovery. Whereas without, many people have done this in the past with array-based replication. So let's say, you had some HP storage or EMC storage. There's some array-based replication solutions like SRDF. Or if you have, two EMC arrays, you can purchase the SRDF solution, cluster-enabled solution. And if you manage the storage on both ends, you can do that. With the cloud, it's not possible because you're not managing the storage in the cloud. So Microsoft's not going to let you replicate your array directly to their array. So the SIOS solution being software-based and storage agnostic, we don't care what type of storage you're using on-prem, and the storage that you provision in the cloud is going to work just fine. So you can have the same type of solution from on-prem into the cloud. So let's take a look at the next slide and hand it over to Heath, who's going to tell you a little bit some more information.
All right. Yep. And up next is Heath Carroll, who's a software engineer at SIOS, and he's going to share with us about what we need to know to get SQL Server clusters up in the cloud. So the first question, Heath, is how do you upgrade SQL or add a node to a cluster? And then secondly, are there any quick start templates that are out there that can get people up and running quickly?
Thanks, Greg. Yes. Both of these are easy things to do in the cloud, particularly with our products. SQL upgrades are pretty straightforward. They don't work really any differently than they would normally. You'd have to take your service, your roles, the things that you're protecting, the applications, put them on a node that's not going to be the node that you're upgrading. Bring the node that you're upgrading out of service, upgrade, bring it back in service, test it, switch things over to that node, and then do the same thing to the node that is now no longer the active node. You would have to do that with both SQL or our product, really. So there's no real downtime for more than maybe an hour to do a 2-node cluster. As far as Quick Start's templates go and our best uses for them, they are really a stand-in replacement for things that IT admins used to have to do, configuring automation VMs, configuring images so that you could deploy, say, 10, 15 computers at once via the Windows DISM tool, for example. Those days are kind of hopefully gone for most people now that we have these templates in the cloud. But if you're not familiar with it, the Quick Start templates pretty much give you a 5-minute task to complete something that would normally take 6 to 8 hours if you were to do it manually. To give you an example of what I mean by that, we can go to the next slide, or I can share my screen. At the top, there are some links for reference. The first one is where I would like to go and show you guys one of our templates that we have up in Amazon, and so I could talk about it with a visual. The other 2 links are links for the code behind this thing. All of the code that drives our personal templates are open source. Almost all of the Quick Start stuff are open for view for both Amazon and Azure. The takeaways from it are, I'm not a big fan of installing SQL. It takes a long time. It's about 14 screens that you have to click through. You have to plan a whole bunch of stuff ahead of time. In the last 2 days alone, I've deployed 5 2-node clusters just for testing. And that's with our template. Just sit down, spend about 5 minutes, not even that anymore. Once you get used to it, it's about 2. Clicking through a couple of buttons on one single screen, and then you're done. Go have a coffee, come back 2 hours later, and you've got a fully functional 2-node SQL cluster. We've got that working in both Azure and AWS at the moment. And so far, the customers that we've had use it have thought it's a great thing. To add nodes to this after the fact, you have those functional images I talked about a minute ago that most IT admins would have to use DISM to create and then deploy via some integrated network through their system. Amazon and Azure have those both in the cloud. We've created AMIs so that all you have to do is go to the marketplace, find the image in either marketplace really, and then just tell it what you want and where you want to put it, and they will put it in the resource group or into the region that you've got set up with your availability set. And then you just have to log into it and say, I want to connect to the cluster. It's pretty much as simple as that. It's not as automated, but fully 2-node cluster automation is there. Adding nodes to the cluster after work is about the only thing that you'd have to do manually. And again, just go to the marketplace and find them. All right, I'm going to attempt to share my screen so I can show you guys the results of some of these things, or what I mean, so you guys have an idea of what it looks like. All right, so the AWS stack generally sends you to a place like this. All right, so if you went on to Amazon, AWS, Google, and searched for AWS Quick Start SIOS, it will bring you here. You could also do AWS Quick Start SQL Cluster, and we'd be one of the first 2 results there as well. The deployment that we kick off winds up giving you something that looks generally like this. From our experience, typically the way that these things work is you have have a design phase where you go out and you lay out and you talk to everybody, you talk to the finance department, you talk to all the rest of your IT folks, and then the AWS guy builds something based on a design diagram given to them that looks like this. They will have a mapping for IP addresses. They will have graphs and charts showing how everything wants to be set up, but the ultimate result is something that looks like this. The thing we deploy with just a couple of minutes of your time and button presses is you wind up getting this AWS region with 2 availability zones. You get a virtual private cloud in there, an internet gateway so you can remote into it, and you wind up getting, depending on which way you do the deployment, you wind up getting 1 or 2 remote desktop gateway servers inside some private or some public subnets, and then you wind up getting 2 domain controllers, a backup and a primary, and 2 SQL nodes / replication nodes. This is configurable so that you don't have to install SQL if you don't want to. You can just install the cluster without SQL if you need to, but this is a SQL webinar, so we're going to talk about that. All right, you'd get up here and just deploy it. Once you had deployed, it would take you to a page that looks like this. It would fill in this link down here. You could change the region that you want to deploy it into via this panel. And then just hit next. No, maybe I'm not on the right page. Let me actually use the link. All right, so same thing. I'll set this to Ohio since I can deploy there. So you hit next. And then you would just select what you want. I want to put this in these 2 availability zones on a 2-node cluster. If you had designed this slightly differently, you could change these settings. But since they're designed the way that they are, I'm just going to leave them as such. You have to have a key pair so that you can log into them later, so anything goes wrong without the domain name. And then you would just choose your Active Directory configuration settings, size, what you want to name it, IP address for both the primary and the backup. You would set your domain name, both the NetBIOS version and the fully qualified domain name. The only few things you actually have to type into here are the passwords you want to use. So restore mode password, domain admin password. This is just for use later. Where you want to access this from. This is just a CIDR address from where you would normally remote into. I'm just going to put it to this so that I can remote into it anywhere. And then the size for the remote desktop gateway. And then finally, the actual cluster configuration settings. Ours are set up for best security practices plus ease of use. You can go ahead and tweak all of these if you want. We do have a pay-as-you-go and a bring your own license version of the AMI available, so you can choose whether or not you want to pay on an hourly basis with pay-as-you-go, or if you want to contact us for a license. Whichever one you want to do, we support it. If we do pay-as-you-go, I don't need a license here. Do need another password. And then whatever size for the default database it sets up, and what type of disk, and then the actual node data. So we've got a lot of available sizes you can use with the product. We've got names you can change, some IP addresses that you want to change, whichever. Whatever you put in here is what's going to get used, but these defaults work right out of the box. After that, these 2 fields you just don't change unless you're tweaking things with your own version of this. You can download the templates offline. Like I said, the code is available, and you can modify them to suit your needs. We've had 2 or 3 customers actually do that, so that's been great. After that, basically it just asks you if you want to name anything specifically. I don't, so I'm just going to go to next. It tells you what you're deploying. It shows you where you can get the code for it, and then gives you an overview so that you can verify your settings before going on. And then you have to acknowledge that, yes, this is going to create a whole bunch of stuff. Please let me do it. And then you hit create and refresh so you can see it. And you would see that it starts to deploy the stack. All right, that would take about 2 hours, and then everything would finish and you'd be able to log into it. I'm going to switch tracks and show you the Azure version of this. All right, so in Azure, I've deployed a resource group using our Azure template, which is set up almost identically to the AWS template. Just has features different because Azure and AWS call storage accounts and resource groups different things. But what you wind up getting with this is you wind up getting a single domain controller here, a primary and backup SQL node, and then all the associated network equipment that you would need. In Azure, we don't use a jump box. In AWS, we do. That is, I think, the primary difference between the two. But outside of that, all the little details are the same. The best part about the templates, I think, is the fact that they've gotten all of the debug worked out. So if something goes wrong, say AWS or Azure have something in the back end that hangs up, or say it just takes too long for the deployment to finish. Sometimes they'll just fail the deployment and you won't be able to proceed. But you can log in and see what's wrong. There are lots of error reporting tools available and pretty much integrated with Windows Event Viewer. So you can just open up Event Viewer and see what went wrong. Maybe you typed in a parameter incorrectly when you put it in at the beginning, or maybe the network stack did not come online when you deployed it. So typically, if there is something that goes wrong, there are tools available to find out what it was, which is fantastic. So like I said, when you get this deployed, it automatically sets up a SQL Server instance for you on the nodes. It automatically sets up replication. The default is volume F in Azure, it's volume D in AWS. It automatically puts all this stuff into place and gives you the ability to switch it over back and forth. If I can remember the correct IP address for this. Network seems to be slow. While I'm waiting on that to complete, you can come here and you can see resources that get set up in your SQL Server. You wind up having the IP resource for the SQL Server itself. You wind up having a cluster. You wind up having a volume. All right, I'll just do it by name. Fine. And you wind up having the DataKeeper replication already set up for you. So if you need to mess with it, add more nodes, add more mirrors so that you can add them to cluster storage, that's how you would do that. You just come and you'd connect to the thing in DataKeeper, add your storage volumes, and move on. It's really, really simple and straightforward. The first time you do it, it might be a little daunting because you have to get your mind wrapped around what are all the settings. But after that, it's a breeze. It's fantastic. It's one of the favorite things about the cloud so far that I have discovered. All right, so I'm going to go back to the presentation. Maybe. Okay, I've stopped sharing my screen. All right, so again, the way that you get to those deployments, the first link on the screen is how you would get to the AWS deployment to go and deploy that. The link for the one in Azure is actually on our GitHub page on the bottom. Azure keeps most of its stuff in a web page in GitHub format. So the easiest way is just to go to that bottom link and you can get to it. AWS does not do it the same way, so you'd have to go to their specified special Quick Start page, which is the one at the top. Again, it's a thriving community of active developers. There's lots of help online. There's lots of examples online of how to tweak templates if you need to tweak them, how to add nodes to stuff in code, etc. It's just all there to look.
All right, thanks, Heath. All right, there's a few more questions, and again, we'll just go through these questions. If Dave, Mike, or Heath, whoever wants to answer these, just kind of jump in. So what are some of the storage best practices?
Yeah, hey, this is Dave. So I guess I'll kick it off. The link here really goes to a great resource that Microsoft's published, and of course it's geared towards Azure. But a lot of the same concepts apply across all the cloud instances. And if you go to this page, it's got kind of a quick checklist. Just say a few things about each checklist item. So your VM size. So one of the great things about the cloud is you're not locked into a certain size when you deploy. So you can increase or decrease the amount of CPU or RAM or storage based upon what you're observing. So if you start out with not enough CPU, you can increase to the next size. But you want to realize that not only your VM size as published might have some limitations that aren't quite so obvious, and one of those limitations is the amount of bandwidth that they allocate you to connect to the storage. So you really have to understand if you're seeing some sort of bottleneck in the storage, it might not be because you don't have enough disk provision. It might be the virtual machine size itself has an artificial throttle that you can't go beyond. So you want to keep an eye on that, ensure that it's not the VM size itself that's causing your problems. And the good news is it's easy to check that, because you can increase the size of your VM and run the same test, and if all of a sudden the problem's gone away, you can have a pretty good idea of where the bottleneck might be. Storage is obviously a primary concern of what storage do you use, how much storage do I use, and again, each cloud provider has different names or different things, but generally there's some sort of premium storage that is going to give you the most IOPS and throughput, and that's where you're going to target your for your SQL Server deployments. So start with premium storage. In the Azure world, there's a new feature that relatively new. I guess it was announced last fall. Managed disk, and that's going to help you to ensure that your disks are optimally placed for redundancy purposes. So prior to that, you kind of had to manage that manually. So if you're in the Azure world, there's a checkbox, use managed disk. Definitely use managed disk for your storage. Earlier I mentioned about the geo-redundant storage. It's a great feature, but for SQL Server, they want you to disable geo-redundant storage, primarily, again, because they can't guarantee that different volumes are going to be replicated and write-order integrity is going to be maintained across those volumes. So you need to be certainly aware of that. And with the storage, the disk, you can leverage storage spaces, and so you can create a pool of disk to increase the IOPS and give you larger disk size as well. So you can leverage that. Just be very careful when you're creating storage spaces that it's best to configure your storage before it's in the cluster. If you try to configure that after it's in the cluster, you're going to run into a couple problems. There's some guides on that, and I've blogged about that on my blog, so just be aware of that. The other thing they talk about is the disk and read caching and write caching. So they recommend that you enable read caching on the disk hosting the log files, and we don't recommend write caching on any of those disks. And then, of course, all your standard, SQL Server recommendations for performance are going to apply here. So they kind of outline all those recommendations, and it's going to be very similar to what you would do for any SQL Server deployment, from enabling database page compression to allocating, disabling the auto grow on your database and auto shrink. So definitely review that document. It's going to give you the best guidance for not only storage but just your SQL Server deployment in general.
All right, great. Thanks, Dave. All right, next question is just related to environments that have a large amount of databases that they want to protect, and just wondering what are the best options for HA for those environments?
Actually, correct me if I'm wrong here, Dave, but I think DataKeeper is one of the best options for this. One of the benefits that we have over things like Always On with SQL is that we can support a much larger number of databases. Like, I don't think we actually have a cap, do we?
Yeah, you're absolutely right. So the block level replication, we were not even aware of the number of databases or the number of files, folders, and whatnot, just ones and zeros on a disk. So we certainly have customers coming to us who have tried Always On, or have looked at Always On availability groups, and they have a large number of databases. And not only is it harder to manage multiple databases and multiple availability groups, but also each time you add a new availability group or new database, you consume more worker thread processes, and so there's going to be a limited number of databases depending upon your instance size. Whereas with DataKeeper, as you add more databases, you're not consuming any more processes on the system. So with a large number of databases is a great sweet spot for us. The same thing for just basic file servers. We have some customers doing very large data sets, or data sets that contain millions of small files that need to be replicated, where any other type of replication solution, whether it be DRS or any other third-party file level replication solution, is going to fall over because it just can't deal with those large types of data sets. So block level replication is a great solution in those areas as well.
All right, the next question is related to whether they should implement SQL Server in the cloud using platform as a service or infrastructure as a service. And if you could just kind of discuss the difference between the two of those and what the recommendations are.
For me, I think the biggest recommendation would be just to try it out, see what works for you. I'm sure that Dave has some very, very specific recommendations, but try it out. That's go in, spin it up, see what's most convenient for you, see what works, and then try the other one and see what works, and then make your decision. Dave, you got anything?
I would say that just for people who are not overly familiar, so platform as a service or infrastructure as a service. Infrastructure as a service is what we've been talking about all day long, where you're managing your own servers and you're deploying your own instance of SQL Server, and it's exactly the same experience that you have today, yet you're running on other people's hardware and in their infrastructure, so you eliminate the need to have to manage that side of the house. So that's going to be your least painful way forward, especially for existing deployments, because you don't have to re-architect or re-engineer or retest anything. It's going to run just like you're used to today. Now, platform as a service, on the other hand, is where the cloud vendor is providing a platform for you to build upon. So they're managing the instance of whether it's SQL Server or MySQL or whatever flavor of their relational database management system that they're offering, and you can build on top of that. And usually there are some limitations. They don't give you the full end user experience that you get when you're managing your own. So like things like reporting services and other SQL Server features, like all the availability features are not going to be available to you. So platform as a service, if I were a startup and I had a green field and I was going to pick one or the other, then I might go Heath's route. I might look at it. It's like, what features does it have? Is going to do everything I need it to do? And am I okay with living without some of those features? And then I might decide to go the platform as a service route. Of course, you have to look at cost as well. So a lot of times, there could be a cost savings with platform as a service. So it's really, platform as a service for existing, people running existing applications is probably going to be much more expensive to do that migration, to leverage that. New instances, it's certainly a possibility that you could investigate.
All right, thanks. Another question is related to trends, and just wondering, are you seeing any trends as far as people implementing more in the cloud, or is it still on premises, still the first place where people are going, or kind of what are you seeing out there when you're implementing DataKeeper for your customers?
Cloud. I mean, it's really incredible the amount of the new opportunities we're seeing are well beyond 50% in the cloud. So it's taken off even faster than I thought. We saw it start 2 years ago or so, and then it has grown exponentially ever since then. So and then I think a lot of it is people are moving to the cloud more and more. But in addition to that, the cloud is really a sweet spot for SIOS and SIOS DataKeeper because they really need us. So I think we're seeing a much larger percentage of the customers that are moving to the cloud. A larger percentage of those customers need something like SIOS DataKeeper to provide high availability, whereas on-prem with virtualization, you had options, right? Maybe VMware HA was deemed good enough, or you had the SAN. You were going to spend $500,000 and get a really robust SAN. So there were certainly more options for people to consider. So it's really twofold: more people moving to the cloud, and we're seeing a higher percentage of those people coming to SIOS for their HA solutions.
We're also seeing an increase in the actual cloud providers. Like first there was AWS, and then Azure, and now we've got Google Cloud. I think we're reading about another one that's coming out. And all these things do is drive prices down due to the competition. So they're all kind of in a race to get you what you need for a lower price, and it's fantastic.
Yeah, absolutely.
Okay, and that sort of leads to the next question about just cost for moving to the cloud. So somebody's just wondering, how are they charged? Is it you just implement and you're charged constantly, or is it only when the machine is running? Do you charge extra for IOs or for CPU usage? Can you just kind of briefly talk about how some of that's done?
That's actually a pretty complicated question. I'm most familiar with Azure and AWS. Both of them charge slightly differently, but there are some things that they do that is exactly the same. For instance, there are compute charges. They do not charge you for your VMs themselves unless they are actually in a running state. So they can be off and not incurring compute charges, and you're not paying for them. Other than that, there are a couple of different options. You can pay by the hour. AWS also has for certain images, depending on who the actual software provider was, you can get a piece of software on a VM for an annual fee. There's bring your own license versions as well, where you could get charged outside of AWS and Azure for the software you're using, but then also have like an hourly cost for the VMs. Depending on the VM size, like the number of cores and the amount of RAM that the VM has actually gotten allocated, you could be charged anywhere from, I think the lowest cost I've seen is free, In AWS and Azure, I think they give you up to $150 worth of free charge, depending on the account that you've got set up. But you can get basically a 2-node cluster set up for, I think I've gotten one down to like $12 a month for really small images in AWS. Typically, they're more than that for a production workload, obviously. They also charge based on the amount of storage that you have allocated. Typically, they charge for bandwidth usage as well, which is kind of a hidden charge. It's kind of hard to track that one since it's dependent upon the user. But I think both AWS and Azure only charge you for bandwidth that is going across the bounds of their cloud. So if you are downloading something from the internet into your cloud VM, they'll charge you for that. But if you're just moving stuff via like a network copy from one of your cloud VMs to another one of your cloud VMs in the same provider space, they don't charge you for that typically. That's just considered a wash. They also, I think, charge you for public IP addresses. Like if you need an IP address to get to your jump box, while you've got that one allocated, it's sometimes they charge you and sometimes you don't. For example, if you don't have that VM running because you don't want to incur the compute charges on your jump box, but you have a public IP address allocated to it, then they will charge you for the public IP address use. But if you have the VM running with that public IP address associated with it, they don't charge you for the IP address itself. So it just really depends on the situation.
Like you said, all the infrastructure charges are pretty much the same across the vendors. The biggest choice that you have to make is whether you bring your own license for your application or you rent it. And when we talk about SQL Server and clusters, that's the biggest choice. Am I going to deploy an image that has SQL Server already pre-installed and pay by the hour, or do I bring my own license? And you're going to have to do the math to see where that break-even point is. And one of the things you have to consider in a cluster, if you rent it by the hour, typically you're going to have to pay for 2 instances of SQL Server, and that's going to double your cost versus if you bring your own license and you have software assurance, you're typically allowed to have a standby server without purchasing an additional license. That's going to save you money. Same with all your third-party licenses. So SIOS DataKeeper, you can bring your own license or you can pay by the hour. So you have the choice there. So they're really the things you need to consider, and they're your options as your applications. The infrastructure, it is what it is, and after your first month, you're going to get a pretty good idea of how much it's costing you to run your infrastructure in the cloud.
All right, well, thanks. Oh, sorry, get Mike.
I was just going to point out that Dave was absolutely correct about the application cost. That's one of our biggest strengths over, say, SQL Always On. If you go to AWS, Always On only offers 4 VM sizes that you can choose from, and they're all pretty expensive. Whereas we offer, I think, 16, something like that, 16 or 20 VM sizes depending on the region, and they range from 1/3 the cost of the SQL AMI to as much as the SQL AMIs you were built off of some of them. So yeah, you got to definitely shop around to find the cheap price, but you can find it.
All right, thanks guys. We're actually out of time, so we're going to wrap things up here. So I want to thank Mike, Dave, and Heath for sharing all their expertise today, and I also want to thank SIOS for sponsoring today's event. The webcast was recorded, and you'll receive a follow-up email with links to view the archive and also download a copy of the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Here's some information too to contact SIOS, some phone numbers, some email addresses, Twitter, etc. So again, take some time after today's webcast to visit the SIOS website to learn more about DataKeeper. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending and have a great day.